Isopentyl acetate, a molecule composed of carbon, hydrogen, and oxygen, smells like bananas. When we burn it, we get 1.75 grams. No, when we burn 1.75 grams of it, we get 1.695 grams of water and over 4 grams of carbon dioxide. From that, they want you to come up with the empirical formula, the simplest formula for isopentyl acetate. This is a combustion analysis problem. It also involves oxygen, so we have to remember to check for that. We'll take those amounts of water and carbon dioxide produced, turn them into a mole ratio of carbon to hydrogen, calculate how many grams we've accounted for by doing that, not of water and carbon dioxide, but for carbon and hydrogen. The rest will be oxygen. Notice they show you the total amount of stuff that they did burn. We'll get the moles of oxygen as well, and then we will convert those C's, H's, and O's, which are now expressed as a ratio, into a whole number ratio. Let's take the carbon dioxide first. 44 grams is a mole. It looks like about 1/10 of a mole, and in fact every mole of carbon dioxide by definition contains a mole of carbon. So we have a ratio for carbon. And for water, well, 18 grams is a mole, but there are 2 moles of hydrogen for every mole of H2O, since it's H2O. And it looks like it's twice as many hydrogen atoms. This certainly looks like a CH2 situation. Don't forget there's oxygen as well then. I didn't do the math, but if you multiply that times a mole of carbon being 12 grams, and similarly you multiply this by a mole of hydrogen being 1 gram, it'll show you how many grams we've accounted for, and it's not all of it. When you do that, you only have 1.3 roughly grams of carbon and hydrogen in isopentyl acetate, so the rest, or 0.4311 grams, is from oxygen. Turn that into moles as well. Here it is. 16 grams is a mole, and that is the mole ratio of carbon, hydrogen, and oxygen. I usually line them all up to make it look like it's sort of done. There it is, and we divide them by the smallest one, which is the 0.02694. That'll make this O1, and these other ones fall into some nicely divided up ratios. Looks like we have to double everything to get whole numbers, and that's a match for C7, H14O2. That just doubles everything. And in fact, that matches isopentyl. There's isopentyl alcohol. This is the isopentyl ester of acetic acid.